All right, we're introducing a new chapter here. We haven't had our Friday class yet, but I'm trying to get this all done so I can get out of here by 4 o'clock on a Friday afternoon. But anyway, I figured you didn't need to see my mug for the intro part. So let's just here we are. We're going to look at basic electric circuits. Now we're only covering sections 18.1, 18.2, and 18.3. I probably should just as a public service do 18.5 just for safety, but I've kind of brought up some of those issues in class and things like that. So, but we're going to look at, now this would be a very, very difficult circuit to solve. And most of the things we're going to look at here are schoolhouse type circuits. First thing we've got to do is look at resistance in parallel and series and parallel series combinations. Resistors work just the opposite of capacitors. Okay, they work just the opposite of capacitors. In other words, the charge that passes through them, well, you'll see. Here, of course, are resistors in series. Okay, V1, V2, and V3. Now, so V1, V2, and V3 all add up to the total voltage that's going through here. Let's say this is a 12-volt battery. Then you'd have, let's say, 3 volts, 4 volts, 5 volts passing through here. I'm just, for instance, you could have 6, 2, and 4 or something like that. It doesn't matter. But look what happens when you do that, because V1, the same amount of charge is going to go through all of them. The same amount of charge is going to go through all of them when they're in series. Okay? All right. The voltage is different. Okay? Same amount of charge, voltage is different. And because V equals IR, so it's a different formula than it is for capacitors, even though capacitors, when they were lined up in series, they had the same charge also. But the equation was just different. What am I talking about? As they'd say in Deadwood, what are you talking about, Woo? Anyway, here we go. My favorite character of all time, I think, in Westerns is Al Swearingen. But anyway, so this is for class 9. I think. Well, it's for class which will be on, see, we've got 10, well, then, of course, 9/11 on Sunday, and then 9/12. This will be for the class 9/12. Okay, so remember, capacitance, Q, was equal to C times V. So when the voltage was different, so when we had the different voltages when things were in series, we had this Q over C thing was equal to the voltage. All right, so you had Q over C was equal to the voltage, and therefore the voltages of each one. So you had Q, the same charge, Q over C total was equal to Q over C1. This is kind of a little review for the exam too. Q over C2 plus Q over C3. With resistors in series, you've got this. So these are capacitors in series. But with resistors in series, you've got V equals IR, Ohm's law. And therefore the voltage, the total voltage is equal to V1 plus V2 plus V3. So therefore, I stays the same for being in series. So I times R total is equal to IR1 plus IR2. And here the Q's all canceled. And so right here plus IR3, what we can cancel cancel the current, and you get R total for series is equal to R1 plus R2 plus R3. Okay, now in the second video, I'll show you what it looks like when they're in parallel.